Hello. In this video I will tell you about 5 most often used types of graphs and how to plot them in Python. So the first one is index chart or line chart. This type of a graph is used when you want to show a time trend. So you should use it when you have some characteristics which changes over time, and this changes of the main interest. The second plot is a scatter plot. A scatter plot allows you to visualize two-dimensional data and show dependency of one parameter over another. For example, here every single point corresponds to a country, and we could clearly see a positive correlation between a GDP and the life expectancy. Next chart is a bar chart. Bar charts are used when you have one numeric characteristic and one or two categorical features, and your goal is to show the difference in numeric characteristic among different categories of your categorical features. For example, here we have a number of bought tickets in different cities. So this is Dublin, this is New York, and this is Portland, and the colors indicate different months. The fourth graph is a histogram, and histogram shows the shape of the distribution of some numerical feature. So here we have an h over x-axis, and the area of every single bar is proportional to the number of respondents of that particular age. Finally, we have a box plot. And the box plot is a simplified and compact version of a histogram. So if you want to compare shape of multiple distributions, sometimes instead of plotting like multiple histograms, you simply plot a box plot. So every single box shows 5 statistical characteristics of a distribution. Central line is median or 50th percentile of the distribution. Boxes boundaries, lower and upper, are 25th and 75th percentiles of a distribution, and lower and upper whiskers could represent different values. In simplest case, it's a minimal and a maximal values of a distribution. Okay, so let's see how to plot these graphs in Matplotlib. So let's start with the line chart. The line chart, let's import the library. Let me restart the notebook. Start. So let's import the library. The first chart is an index chart or a line chart. It simply asks you to provide two vectors of the same length, vectors x and y, and then it plots a line through these points. So the first point is 5, 1, second point is 5, 1, second point it's 10, 2, right, 10, 2, third point is 23, 23, and the fourth one is 30, 34. So the order of the points matters, right? So here we have completely the same set of coordinates, but the order of the points is different, and the order matters because you plot a line through the points. Like you start with the first point, you go to the second point, then to the third, and so on. If we want to add some labels to the axis, we could do it using a command y label and x label. It will simply, so let me execute this. It will simply add labels to the axis. Let's also increase the font size of a Matplotlib, so all our picture will have bigger numbers and bigger letters. So we could control the color of the line, and you could use different colors. There are some shortcuts, for example, R for red, blue for blue, G for green, K for black, and so on. You could also use some named colors. you could follow this link and look for different color names. Alternatively, you could use a hex color encoding. For example, I like this service very much. Okay, so you could also change the style of a line. So here the only difference here, the color and the line style is dashes. Yeah, right. So let's see, shift up. Let's see the options for this line style. Let's try something different. Let's try maybe, so this will be dash dot, dash dot, dash dot. So you could have different line styles for the lines. We could add a title to our plot, simply put plt.title and then a text, and the title will appear right here. We could have multiple plots, multiple lines on a single plot. So this will plot two lines, the red one here and the magenta one right here. We've used different line styles to separate them. We could add some legend. So if, let's say, if you want to mark the information about line styles, right, and you could create a legend, and the legend, you simply need to create a label. So compare this to this. The only thing is different. We have a label here, and once you have a label here, you need to type PLT legend afterwards. So if you don't put a PLT legend, you don't have a label, and once you put it, you have a label. So the next plot is a scatter plot. The scatter plot, so the notation, the form of the usage is basically the same. You pass x coordinates, list of x coordinates and list of y coordinates, and the order, as you could guess, doesn't really matter, because we don't plot a line, we simply put some points on the plane. So let's add more points. Again, let's add some labels. So you could see that the function to plot these points is different, but the functions to add x labels, y labels, title, legend are all the same. So let's set some color to these points. In this case, again, we could do it in a different ways, but one of the ways, you simply pass a vector, number of values in this vector should coincide with number of points that you plot, and if you just want to plot different points with different colors, so for 2 points that needed to be plotted with a different color, you should use different numbers in this vector. So if you don't like this yellow and violet colors, you could use different color map. And basically the color map is a predefined set of colors. So this vector x here is completely the same vector as here, but we use a different color map. Okay, and now instead of yellow and violet, we have what is it? Red and gray. Right. We could increase marker size. So there is a parameter s here, and again, you could look for all the parameters of a scatter plot. Put your cursor inside the brackets, press Shift plus Tab, and read all the information. All the parameters are here. All the descriptions for these parameters are here. So we could increase the marker size. We could change a style of a marker. So instead of circles, it could be squares, or it could be triangles, the parameter which controls the form of the marker called marker, and there are some other options like, for example, a star. So let's download some more data for our next plot. So it's basically the same data as here, just more information. It's a height, weight, age, and a male or female. So let's just plot more data. This is how it looks like. So here I also changed the size of a figure. So you could see the figure was small. Once I put it here, the figure is large. So the first number is the width of a figure, and the second number is the height of the figure. And actually, yeah, so the first number is the width and the second number is the height of a figure. So let's move on. The next plot is a histogram. And again, histogram is a type of graph that shows the shape of a distribution of your data. So let's take a short look here. Height, set of numbers. So you simply pass the whole column into the function hist, and it will automatically choose some borders for the bins, and it will compute number of observations that are in these bins. So let's see how it looks like. So if we actually save the outputted values to the parameters bars and bins. So bins are the borders. This is the leftmost border of the first bin. This is the right border of the first bin, somewhere here, and the bars are the heights of these bins. So let's, for example, see this bin. It's one of the last ones, so it's I guess this is the one, and its height should be about 100, like more than 150. So it's either, I guess this is the one. It looks right to me. So we could check it. Let's check, for example, for the very first bin. We want to know how many observations have height between 53 and 66, right? So let's see. Let's count them. Let's take a shape. So it's exactly 11, right? And if we change, let's say we want to check for this second bin, all the observations higher than 66 and shorter than 78, 80, right? So this, no, all right. So what parameters do we have for the histogram? We have an obvious parameter, number of bins. We could increase number of bins. So again, I added the X label and the Y label just to make things clear. We could change the orientation of a histogram. So instead plotting it, how do you say it? Vertically, you could plot it horizontally, or vice versa. So the original one is horizontal. Yeah, right. So instead of plotting it vertically, we could plot it horizontally. We could plot multiple histograms on a single plot. So we could do it in two ways. This is the preferable way, but there are like, you could do it in multiple ways, but this is probably the preferable way to do it. So here the two different histograms are corresponding to the males and females. We could add labels. So in order to add labels, we need to pass a parameter label and specify which histogram is what. We could change the color of our histograms. Again, we need to pass a color. So I pass here a list because I have two separate vectors to plot a distribution. But if I only want to plot the distribution of heights of women, I need to pass only a value, not a list. All right. See? Okay, and basically this is it for the histograms. So the next chart is a bar chart. And a bar chart, the difference from the histogram is that we don't actually pass a vector of values. Instead, we pass two vectors. One list is basically the x position of the bars, and the second list is the size of these bars. So obviously you could always plot a histogram using a bar chart function by computing like manually all these bins and their heights. Yeah, but you better not to do that. So this is a bar chart. Again, let's set some labels. It's slightly different. This is a labels for every single tick. We could change the color, again providing a list of colors right here. We could change the width of every single bar right here, parameter width. We could make it horizontal. It's actually a different function here. So this is a bar and this is bar h. We could add a grid. So this is, let me show you. So this is a grid. I added only a grid over x-axis, but I could add a grid line over both axes, you see, or only over y-axis. But I prefer it that way. And we could also change the x ticks. So instead of 0, 50, 100, 150, change it to 0, 30, 60, 90, like that. So the next graph is a pie chart, and I personally don't like pie charts. I think you could, and this is obviously true, you could plot any pie chart could be changed by a bar chart with like it will be only a win. But since some of you actually love pie charts, I guess I need to show you how to plot them, how to configure them, so they would be slightly better than usual. So with a pie chart, you simply provide a set of numbers, and these numbers will be the segments of the pie. So this is a list of numbers, list of sizes. What is it? It is, so the first number is number of males and the second number is number of females. Second, we could add labels to these segments, right? We could change a starting angle. So move the starting angle to the 90 degree. We could put some numeric values on pie pieces right here, like percentages, using this parameter. So basically this parameter, what it says that by default it's a percentage, but I asked it to configure to round these percentages to 1 point after the floating point. Okay, I could change it to 2. It will be 2 points after the two digits after the point. I could put it 3 digits after the point, so on and so forth. So if you, instead of these percentages, want to display something else, like the numbers, you could define a specific function, and you could pass this function to this parameter. And the number that goes into this function will be a percentage of a segment. And then you need to pre-process it in such a way that it will represent the value that you want to show. In my case, I want these numbers be simply a number of females and number of males. So I divide this percentage by 100 and multiply it by a number of observations in the data. So I end up with a number of females and males. We could add an explosion. Number impulse is not defined, my bad. So we could add an explosion. So this white space between different segments of a pie. And the explosion is a list of numbers, and for every single, so the length of this list should be the same as the number of segments in a pie, and for every single segment, the number 0 represents 0 explosion. You see no explosion, and like increasing this number will increase the distance, the white distance. So let me put like 25 here. It will be bigger. So next, what could we do? We could actually, so what we do here, we simply add more segments to a pie chart. Again, we change, so this plot, we change the customization of this, of these numbers displayed in the segments. We could change a radius of our pie using parameter radius. We could make a donut chart instead of a pie chart. This is controlled by parameter wedge props. So wedge props is basically the width of a segment. And since the radius is 1 and the width is 1, the radius is 2 and the width is 1, this is a donut pie. So if I change the width to 2, it will be a simple pie chart. If I reduce it, let's say 0.5, it will be a big donut. If I put it 1, it would be a smaller donut. So again, this width should be smaller than a radius. Let's see what if we do it bigger than a radius. The picture gets messy, so don't do that. So this width should be smaller than a radius. Finally, we could add a title. Again, the title is added in a similar way as always. Simply plt.title and then str with a title. So finally, we have a box plot. And again, box plots are used when you want to represent a distribution of a data, but not a single distribution, but multiple distributions. So you could use it for a single distribution, but it's less informative than compared to histograms, right? So the histograms show you the, let me go back. So the histograms show you the complete shape for every particular value of your feature. It gives you the information of how many observations with this particular value are in your data. And box plot show you only different statistics, different statistical measures of this distribution. So let's go back here, how to plot them. So I will just skip all these cells because I personally prefer not the matplotlib version of a box plot, but a Seaborn version of a box plot. And a Seaborn is a library built upon a matplotlib. It provides some cool functions that allows you to plot beautiful graphs relatively simple, in a relatively simple way. So this line here, I simply create a feature, a column gender. So this is the original data, and I create a column gender. So it's a male if the original column was 1, it's a female if the original column was 0. And yeah, basically Seaborn box plot works the following way. You pass your data, you pass the column that you want to represent a color. In my particular case, it's a gender, and you pass a column that you want, like your actual feature. So your actual feature is a height, right? So if I remove a gender from here, I will end up. So let me do that. I will end up with a single box. You see, a single box for all genders. But if I add a gender here, then magically this single box splits into two different boxes, and these boxes represent the distribution of heights for males, and these boxes represent the distribution of heights for females. Again, we could change a width. Let's say, you see, the width of the boxes. We could change the orientation using parameter orient. So let's compare. So why do we want to use box plots? So instead of these messy pictures, we could see if our goal is simply show that the male's height is on average larger than female's heights, then the box plots, like, they're doing job much better than histogram here, right? So here the data is completely the same, but the graphs are different, and to my point of view, box plots works better here. So we could use some picture like that. So what is going on here? Again, we had the column age. So what I do, I added a new column age group, and the column age group is the following. So if the age of the person is less than 3, then it's a baby. If it's between 3 and 13, then it's a child. If it's between 13 and 21, it's a teenager. If it's between 21 and 50, it's an adult. And if it's older than 50, it's a senior. Like simple, like 5 categories out of my head. And next, so we added the parameter HUE. This is without this parameter. This is with this parameter, and we increase the size of a figure. So now, instead of 2 boxes, we have these two groups, male and female, and inside every single group we have boxes of different color, which represent like all males of a specific age group. For example, all baby males, all child males, so on, and the same thing for the females. Okay, so this is it for this video, and I suggest you to watch these great web pages with more examples on Python visualization with Python. Goodbye.